Hello, welcome to this third in a series of presentations I'm giving on slide rules. Um, Today I'm going to talk about the Hemmi 257 slide rule. I'm not sure the exact name. Some people say it's the chemistry slide rule, others say it's the chemical engineering slide rule. But it's a bamboo slide rule put out by Hemmi starting in like 1954 or so. And I'll give a overview of what I'm talking about with this. We'll go a little bit about the background and history and talk about when the slide rules were made, how you can tell if you've owned one, when it was made. Comparison with some of the traditional slide rules that Hemmi put out in the 50s and 60s. I'll go over the remainder. Will go over the scales involved with these slide rules, the atomic element and molecular group marks, in how you can do conversions between mass and mole fraction or mass and volume fraction. And some of the neat things you can do with temperature pressure conversions, and also real basic calculations on doing adiabatic compression of air or CO2. And finally, one of the more useful ones is looking at the steam tables on this. You had the built-in steam tables really on this slide rule. The background, as far as I can tell, this slide rule was started manufacture in the early 50s, maybe mid-50s, like 53, 54, something like that. Most of these slide rules have a date code on them, Hemmi, some don't, but you'll usually find it near the Hemmi, Japan, and this FL is a date code. So we go down here, F is starting in 1955, L is the month, so it was, this particular slide rule was 1955, later 1955. Like most of the Hemmi slide rules are made out of bamboo, very stable product, slides very easily, just feels very high quality. And I'm not sure what the cost of these were when they first came out, but I got a feeling they were pretty expensive. At least the specialty ones were. Maybe the standard Hemmi slide rules were comparably priced with K&E or some of the others, but it's a very good slide rule. This particular one is well cared for. You can pick these up on eBay if you can find them for anywhere from $100 to $300. So it varies widely. You just have to park yourself on eBay and do a watch for them. And they come up sporadically. I got this one last year for about $89, but I had to pay a little bit of shipping. So it was about almost $100 by the time I got the slide rule. Next, we'll go into the specialty scales. I've kind of got the scales sort of marked out here in split form just to show you. The top scale starts off with the chemical element listings. And what you have to look for here, all these are different elements. They've, not the entire periodic table obviously, but different elements they've listed. And you're able to put the cursor on these marks, say like for oxygen, and then that corresponds to the back scale, the molecular weight of oxygen. In this case, if you look at the D scale, it's right at 16 or 1.6. Now the key is knowing where to put the decimal place. So if there's no mark, you see some of these have a bar on the top, some have a bar on the bottom, like hydrogen has a bar on the bottom. Oxygen does not. So if there's no mark, you multiply it times 10. If there's a mark below, as in hydrogen, obviously is 1 or a little over 1, but then there's no multiplication factor. If you take like a heavier element, such as let's go for Au, gold, the top, there's a bar on the top which indicates that whatever number you read on the D scale, you multiply that times 100. So it's a 197 or something like that, 196 for gold. So this is a pretty nice way to have molecular weights at your fingertips. There's also molecular groupings like NO2, SO4, PO4, and so forth. You're able to get molecular weights without, saving a little bit of addition, which was kind of a pain in those days without a calculator. Next on, we have the the M1 and M2 scale. These are very useful in converting mole fractions, mass fractions to mole fractions. And what you have to do is for like M1, you would enter the first molecular weight divided by M2, the next molecular weight. So in case, if we had an example of, let's say water and sodium chloride, we would, sodium chloride has a molecular weight of 59 or 58.4. So we would go to the first molecular weight, almost 60, 58.4, right here. And then we would divide by the molecular weight of water, which would be 18. Okay, and that sets our molar or molecular weight ratio then. Then on the other part of the scale, we have an XW, which would be the weight fraction. So say we had a 10% weight fraction of sodium chloride and water. So we put the weight fraction to 0.1, and then read right below that, looks like about 0.033 there on the X scale, and the X scale was marked here by X. So X is weight fraction, and X of W is weight fraction, X is the mole fraction. And if we use the molecular, instead of molecular weights, we use the density, we could use the weight percent to the volume percent to do the same sort of calculation for that. So it's a, the weight fraction, mole fraction is an easy calculation, but somewhat tedious, especially, if you're an undergraduate like I was in the late 70s. These would get very tedious to do if you do a whole lot of them. And the beauty is, once you set your molecular weight ratio or density ratio, you've got essentially a spreadsheet of different weight fractions that convert to mole fractions or volume fractions. So a very useful tool. Next up on the slide is simply just the degrees C, degrees F, and degrees Kelvin. So you can easily convert between the different temperatures. So if we had minus 100 degrees Fahrenheit, you could read down the cursor and get your conversions to degrees Kelvin and degrees C very easily. Next up is the another one called here F sub T, F of T. It's basically a function of air. You're able to do adiabatic compression numbers on this. So say like we had one example, if I had air at a certain pressure, and I first look at my pressure, atmospheres, go over here, and I say I've got air at 1 atmosphere. And if I move my cursor over to, say, air at 25 degrees C, okay, that's F of T at 25 degrees C, hovering right over the 1 degree, the 1 atmosphere mark. And if I want to compress that, say, to 10 atmospheres, I would just move my cursor up to the pressure is equal to 10 atmospheres, and then I'm just shy of 300 degrees there. So you can these are probably within 1 or 2 decimal places, or 2 decimal places at least. And you can do the same thing. There's an F of T for CO2 if you do the same sort of calculations on the scale just to the right of the slide. Okay, so that's a pretty handy little calculation. What I like most, I think, about of this is the ability to do temperature calculations with saturated steam. So the very bottom scale on the bottom stator is a T sub W, and that's basically temperature of water at saturation. So we could do an easy one here. We all know, like 100 degrees, I can set T equal to 100 and look up at the pressure scale, whatever units I want. What's 1 atmosphere? So the saturated pressure at steam at water at 100 degrees is 1 atmosphere. And you can do this for lower pressures also. If you want to look at 40 degrees, see. Go up and look at whatever units you want to look at, millimeters of mercury or inches of vacuum. You can get direct readings of whatever vapor pressure water is at that temperature. So all in all, a very useful tool, even for today. I think if you don't have a computer handy or a spreadsheet handy, or don't have these molecular weights or steam properties at your fingertips, this would be a good secondary slide rule to have on hand. Unfortunately, the backside is a more traditional slide rule, but it's not very useful in my opinion because it doesn't have an A and B scale. It has an A scale and a folded C and D scale and a regular C and D scale with some log functions here that you can use. But there's no cube scale. I think on a later model, the 257L, they put a K scale on here. But to me, it would be nice to have sine, cosine. But I think probably the logic in this was a lot of industrial chemistry calculations, you don't really use trigonometric functions that much. So that's what it was. And it's basically the same dimensions as a Versalog. Same cursor, same dimensions, same build, same materials, same cut of wood. And so I think if I were an engineer in those days, I would actually have both these handy just to do some of my other traditional calculations, sine and cosine. A little more usable slide rule for overall purpose. So I don't think it's not a standalone slide rule. I think if I were to redesign this, I would put an A, B, C, D scale and get rid of the folded scales and put in some trigonometric functions that would probably make it a more all-around slide rule. Anyway, that's it. Hopefully you can find one on eBay. My recommendation would be just park on eBay and wait, put a search on for this Hemmi 257, and eventually they do come up. But you might have to pay a price if you get other bidders that are online because, like I said, they can go. I think I got this one at a bargain at $89. Mostly they're upwards of $100+. So good luck on your slide rule collecting. Bye.